just AX, right? So this is a conjunction. The major operator here is a conjunction. This is a conjunction of a simple existential statement and a propositional function, which is weird. We don't want to have translation of sentences to have subformulas that are propositional functions, because propositional functions are not true or false, right? So they're incomplete. And if a subformula is incomplete, the formula is itself not determinable as true or false. So this says something weird. This says the major operator is a conjunction, right? The form of this thing is a conjunction, whereas the form of this thing is an existential statement, right? The scope of this quantifier goes all the way to the end of the formula. This is in quantified form, which we learned from Unit 14. This says there is something that is both Australian and a surfer, or some Australians are surfers. That is what this says. This is correct symbolization. This is not. This is wacky. This says this is a conjunction. The major operator here is a conjunction, and the two conjuncts are, first conjunct, Australians exist. This says there exists an X such that X is an Australian. Australians exist, and X is S. X, what is X? X is an individual variable. You don't want individual variables unbound, right? So this is equivalent. This means exactly the same thing. This wrong attempt to formalize some Australians as surfers means exactly the same thing as if I had a Y here or a Z there, right? It says there exist Australians and Y is S, or Y is a surfer, right? It's incomplete. It's no good. It's a conjunction with one of the conjuncts wrong. She has a symbol. Yeah, you can read this off. She has a she has a symbol thing here. Is this bottomer 234? If we omit the parentheses, this is in the final paragraph of 234, we get a funny kind of expression, one that is not categorical. She's got cat and striped. If CX means X is a cat and SX means X is striped, for instance, the formula that's equivalent to this, CX dot SX, does not say that some cats are striped. This is because the X in SX is not in the scope of the formula, is not bound, and so does not refer back to the quantifier. It stands on its own. It's a free variable. The formula would be read, there are cats, and X is striped. It is a conjunction rather than an existential proposition, and has as its right conjunct a propositional function. That's no good. That's not what you want. All right. So that's wrong, right? You don't want that. You want this. The crucial thing I was stressing, right? You got to read this as there exists some one X, one being there is one for which these two things are true. There's at least one which is both Australian and a surfer. That's what you need to get some Australians are surfers. That's what I'm saying. Okay, and that's the way to get at this X, which is one individual in both subject class and predicate class. Particular inclusion. That's what particular inclusion is. That's the logical form of particular inclusion. If you understand all that, particular exclusion is pretty easy. Particular exclusion, O form, some Australians are not surfers. Our Venn diagram of this proposition was putting an X over here in the area where the individual is in the subject class but is excluded from the predicate class. Some Australians are not surfers. There is at least one thing, which is an Australian, that is excluded from the predicate class, the class of surfers. So there's an X here, right? Logical form of that is this. Sorry, it's a bit cramped here. There exists an X such that both, right, that's a conjunction, both X is Australian and X is not a surfer, okay? So there exists an X, we've got a conjunction, propositional function is a conjunction, subject class, and negation of predicate class. Again, make sure you read it so you're seeing this as I'm asserting both these things are true of the one individual. There exists at least one X, at least one of them, one thing, of which these two things are true. What two things? It's Australian, it's not a surfer, right? The predicate Australian belongs to it. The predicate is a surfer, is denied of. It is an Australian non-surfer. There exists an Australian non-surfer. Some Australians are not surfers. Okay? Notice the the fact that in both of those two forms, the existential quantifier goes with the dot, right? The I form was this, and the O form was this, right? We're now going to see, we're going to do the A and the E form, universal inclusion, universal exclusion. I'll start a bit part for that. And that's going to be the universal, this is going to be the A form, as we'll see, and the E form is going to be this with a negation for the predicate. And it is very crucial that you take away from this chapter that the 4 logical forms for categorical propositions are, right, this. 1, 2, 3, 4. Hammer it into your brains that the universal quantifier goes with a hook and the existential quantifier goes with a dot, right? Because those basic logical forms, the big thing you need to take away to see what's going on in Unit 13, which is very hard and complex, but necessary for going forward, the big thing to take away is that these are the 4 basic logical forms of categorical propositions. Because in Unit 13, what we'll be doing is putting really complex subjects and predicates into these positions, but you will, if you don't recognize or realize that they've got to slot in to these, they've got to slot in or be structured by one of these 4 particular logical forms, right? That one, that's A, this one, that's I, those are the 2 positive ones, and then from nego, this one will be E, and this one will be O. If you don't realize that, when you do the translations and you symbolize a whole bunch of stuff, you're going to get away from the basic form. It's a very similar lesson to when we were doing translations in sentential logic, and I said, what's the first thing you do? You identify the major operator and put that down, right? If the major operator is a conjunction, if the whole thing is an and, put that down first. Boom, dot in the middle, put brackets on either side, and write those in English, and then go and translate those bits, because when you translate those bits, you keep the overall logical form in place when you then translate the bits. And that's the most important thing. If the first thing, identify the major operator first, it's a conjunction, keep the thing a conjunction. Don't try and symbolize all the things at once, because you're very unlikely that the final thing will have the final translation will have as its major operator a conjunction. Okay, all right, we'll come back and we'll do logical form for A and E.